Hello everyone. Today I'm going to present the work developed by our research team at the Biomaterials Laboratory at Centro de Física Aplicada y Tecnología Avanzada of Universidad Nacional Autónoma de Mexico, titled Synthesis and Characterization of Alginate-Based Hydrogels Derived from Sargassum for the Design of Controlled Drug Delivery Systems. As many of you know, the massive influx of pelagic sargassum on the Mexican Caribbean coast has transitioned from an ecological anomaly to a severe environmental and economical crisis. However, instead of viewing this simple as a toxic waste, our research group approached it as an opportunity. The main idea of this project is to implement a strict circular economy model. We aim to valorize this invasive macroalga into high-value biomedical materials using entirely green chemistry principles. Specifically, we designed a cascaded biorefinery process to extract polysaccharides, reusing the leftover waste, and formulate hydrogels loaded with phytochemicals, in this case acetogenins, for the potential controlled drug system, for potential controlled drug delivery. If you look of methodology section, you will see that our process is divided in four main integrated stages. In part 1 and 2, we completely avoided the use of toxic solvents. Instead, we synthesized a natural eutectic solvents or NADES using choline, chloride, and urea. Using this green solvent combined with ultrasonic extraction on dry sargassum, we were able to efficiently disrupt the biomass. And from that extraction, we subsequently isolate a purified 2K polysaccharides, alginate, and fucoidan. Okay, and commonly in a traditional extraction, okay, the remaining solid biomass is discarded. In our closed loop model, we took that exact residual biomass and subjected to a solvothermal reaction to synthesize carbon quantum dots, and also we obtain hydrochar in the as product. But in part 4, the hydrogen formulation, we use the isolated alginate and fucoidan to synthesize our hydrogels. We create three variations: a reference hydrogel, okay, this is composed of fucoidan and alginate. Another one incorporating our carbon quantum dots, and the three fully loaded is hydrogel loaded with the acetogenins and the carbon quantum dots, of course. Okay, as a preliminary results, we have successfully validated this proof of concept from a material science perspective. Okay, in Fury 1 shows our FTR spectra. The characteristic bands confirm that successful extraction and structural integrity of both the alginate and the fucoidan, as well as the successful cross-linking in the hydrogel matrices. In Figure 2, you can see the characterization of the carbon quantum dots. Okay, the 10 micrographs, this transmission electron microscopy, this micrograph and dynamic light scattering confirm their nanometric size, okay, the nanometric size of the carbon quantum dots, and the excitation emission matrix verifies their fluorescent properties, which are highly useful for the future biomedical tracking that we can use these materials. And finally, in Figure 3, this displays the same micrographs of our hydrogels. You can clearly observe highly porous interconnected microstructure. This porosity is exactly what we need for a drug delivery system, as it allows for the proper swelling and eventual release of the loaded phytochemicals. As a conclusion, this study successfully demonstrates a highly sustainable closed-loop circular economy model. We proved that we can take a problematic invasive species, extract valuable structural polymers using green solvents, turn the waste into functional nanostructures, and assemble them into a composite biomedical hydrogel. Uh, I do want to emphasize that these are all preliminary structural results. Our foundation is solid, but the next crucial steps involve depending this research. We are currently working on evaluating in vitro swelling kinetics, the specific release profiles of the acetogenins, and the performing the necessary cytotoxic assays to fully validate the potential as a controlled drug delivery system. And of course, I'm not in this moment in this poster. I'm not presenting all the results of the materials because we are preparing a publication, and I only show you some of the results. And thank you very much for your time. I will be happy to discuss our green extraction protocols or our hydrogel formulation if you have any questions. Thank you very much.